I will be just starting with the yes. So today's point of discussion is statistics. In the previous classes also, or in the introductory lectures, whenever we discussed about introduction of statistics to engineer, it was in the previous centuries, whenever it was invented or discussed by a great mathematician, it was only generated, or this theory was developed only for the purpose of the political state affairs. But later on, now in day-to-day life, engineers, may it be scientists, may it be researchers, may it be people belonging to the industries, everywhere we require the information, right? That particular information or data which is available with us has to be processed for certain outcome, or for certain results. After doing the analysis, we arrive at a certain conclusion, or we draw certain conclusions, right? And for that purpose, the statistics plays a very important role. So in the beginning, we just go on with the introduction, that in certain applications of engineering, we always find out certain relationship between two variables by means of algebraic or transcendental equations with the help of values of variables. See, whenever we talk about the subject mathematics, calculus comes into the picture. Calculus comprises of the derivatives and integration, and the beginning starts with the function. Function involves variables. So what do we actually know with by variable, or what is the meaning of a variable? Usually the variables are denoted by the alphabets x as well as y. The small alphabets or the notation used is small x and small y. So statistics always helps us to find out the relationship between two variables by means of algebraic or transcendental equations. Now, what do you mean by algebraic equation? Algebraic equations are those equations which are termed as polynomials. So in general, a quadratic equation is also a polynomial. When I am writing down x square plus 2x plus 5 is equal to 0, we identify this particular equation as quadratic because degree of this equation is 2, and this is ultimately a polynomial. So the equation of the type f of x is equal to 0 is called as a polynomial, or we can term it as algebraic equation, which is purely containing a variable or the polynomial terms. That kind of equation is called as algebraic equation. Now, in turn, or on the contrary, what do you understand by transcendental equation? Though here the alphabet n is used, but that n is silent, so it is not transcendental equation, it is transcendental equation. So the equations which are not algebraic, that means those equations are transcendental equations. Now, in other words, I can define transcendental equations as an equation which contains logarithmic terms, exponential terms, trigonometric terms. Such kind of equations are called as transcendental equation. This is purely a polynomial because it is containing a variable x, x square, right? The equation which can be written in the form as x e to the power x minus sin x is equal to 0. This is also equation of the type f of x equal to 0. But this f of x is not purely containing variable x. It is involving the exponential term. It is involving the trigonometric term. So I can call it as, or term it as, transcendental equation. So certain applications of engineering, we always try to find out the relationship between the two variables with the help of values of variables. These values of variables will be obtained by certain methods which are proposed in theory of statistics. So in theoretical engineering, the lines of regression can be regarded as fitting of linear curves to the given values of variables. One of the topic what we are going to discuss in the coming course of time, or in due course of time, is lines of regression, coefficient of correlation, which is extension part of fitting of a curve. So theoretical engineering, the lines of regression can be regarded as fitting of linear curves to the given values of variables. In practical engineering, we are required to find a functional relationship between two variables, say x and y. Usually dependent variable is taken or considered as y, whereas independent variable is taken as x. So whenever I'm expressing a linear relationship between x and y will always be taken in most of the cases as a dependent variable and x will be treated as independent variable. So whenever I am saying that f of x is equal to y, so y is a function of x, means if I change the value of x, I will be getting different values or set of values for y. So in that case, in turn, this y becomes dependent on x. Therefore, x is termed as independent. Now, the usual definition or the terminology what we always require is a variable, which is also called as a variate. A quantity which can vary from one individual to another is called variable or variate. See, it depends on assumption. Variable means it is never fixed. Other quantity opposite to this variable is constant. Suppose I take constant c is equal to 5. In any part of the world you go, 5 will be treated as 5. There will be no change. But as a variable, if I'm taking it as x, in certain example or a problem, x can be 5. In certain example, x can come as minus 2 by 3. So it is never fixed. It can vary from individual to another, or it can vary from situation to situation, or from example to the other example. Suppose weight of a person or weight of any object is always variable. Sometimes it may weigh as 70 kg, sometimes it may weigh as 1 kg, right? Ages, it is there is increase in always age, increase in height, or stagnancy after one certain stage. Rainfall records of cities, these are all quantities which are always variable, which cannot be fixed to a certain which cannot be fixed to a certain term, right, or certain values. The other terminologies or the concepts related to the statistics comes out as mean, median, and mode. What are different kinds of mean? Arithmetic mean, geometric mean, or harmonic mean. You must have learned geometric mean and arithmetic mean, you must be aware of. So how you calculate arithmetic mean for a particular given set of observations? If x1, x2, x3 up to xn are set of n values of variate, then arithmetic mean or simply mean is denoted by x bar, and what it is? Sum of all the observations upon total number of observations. Suppose I have the number of observations as x1, x2, x3 up to xn. N number of values are given. Here they are mentioning that how many values are there? N number of values are there. So simply mean, or which is also called as arithmetic mean, is defined as x bar, which is sum of all the observations upon total number of observations. Total number of observation is denoted by n, and mathematically this particular step is written as summation of xi upon n, where what is I is varying from 1 2 3 up to n. So n values of observation is available, sum of all them. This summation sign signifies addition, right? So x bar will be summation of xi upon n. So I will be taking down sum of all the observations divided by total number of observations. What is median? You are all familiar or you have heard about this. If the values of a variable are arranged in ascending order of magnitude, the median is the middle term if the number is odd, and it is mean of two middle terms if the numbers are even. Suppose you have total number of observations as odd number, that is 1, 2, and 3. So what they are saying, this particular observation, when they are arranged in the ascending order, median is exactly the middle term when there are odd number of observations. 3 is an odd number, total number of observations are 3. So on the left of this middle term, one observation exists. On the right of this middle term, one observation exists. So therefore, I can say that this element which is present is at a median position. So what will be the median of this particular set of observations? 2 will be the median for the given set of observations when the number is odd. When the number is even, when same observations are taken but number of observations are even. Suppose it is -1, it is 0, it is 5, it is 6. Total number of observations, if you count them, are 4. In such cases, we have to take the mean of these two middle terms so that it will be called as median. So, and on the left of these mean, equal number of observations, and on the right there will be lying equal number of observations. So median is that particular value if the values are arranged in ascending order of magnitude, and median is called as the middle term if there are odd number of observations. If there are even number of observations, we take the mean of the two middle terms. So this is all about the median. This is also a term which is associated with the statistics when we actually start with the study. Mode. Mode is defined as that value of the variable which occur most frequently, means the value of the maximum frequency. Maximum frequency means that particular number is occurring or appearing many times. So we say that the particular number is having more frequency. More frequency means that particular count will be termed as mode. The mode is defined as that value of the variable which occur most frequently. Suppose in an observation the number 1 is repeated many times, right? So 1 will be the mode for the given set of observation. See, obviously statistics is always associated or connected with the data. Data should be provided by any means it is collected. After the data is provided, we will start our analysis depending on the knowledge of statistics what we have. So mean, median and mode are basic terminologies which are associated, and these are also called as measures of central tendency. Mean is nothing but average. For all given set of observations, mean is called as average. So all these values are associated with the central tendency, and mean, median, mode goes always in hand to hand. One of the type of mean what we discussed, which is also called as simple mean or denoted as or called as arithmetic mean. But various kinds of mean which are also available with us are geometric mean and harmonic mean. Just for your knowledge upgradation, I'm sharing this particular thing with you. If x1, x2, x3 up to xn be the n values of the variates xi, then geometric mean is denoted by G, which is product of all the observations raised to power 1 by n. Whatever will be the total number of values, those values will be taken into the product form, and that much power in the fractional form will be raised. So that particular quantity will be given by or will be called as, referred to as geometric mean. Suppose there are two observations, 2 and 3. So 2 into 3 raised to power 1 by 2 will nothing but be the geometric mean for that particular set of observations. Here x1 is equal to 2 and x2 is equal to 3. So how many observations are there? 2 observations are there. So my job is to take the product of those observations and raise to power 1 by n, where n stands for number of observations. So 6 to the power half or under root of 6 will be called as geometric mean for the given set of observations. Lastly, it is harmonic mean. If x1, x2, x3 up to xn is the set of n observations, then harmonic mean is defined as reciprocal of the arithmetic mean. Arithmetic mean means x1 plus x2 plus x3 up to xn upon n. Take the reciprocal and add them. So that will give you the reciprocal of the arithmetic mean, called as harmonic mean. So 1 by h is the notation used for the harmonic mean, which is 1 by n into 1 upon x1 plus 1 upon x2 plus 1 upon x3 up to 1 upon xn. So that is all was about the topic or the brief introduction of the topic or the heading, that is statistics. I hope this much part is clear to everybody. That in